There are patterns everywhere around us. We see them in real life. You can look around yourself and you'll see so many patterns around the buildings, for instance. Those there are definitely number patterns, and we can turn all that into a mathematical problem. That's another very nice pattern there, which can also be turned into a maths problem. You know about that. We could have like that as pattern 1, and then have that as maybe our pattern 2, and then pattern 3. Already we have a number pattern because we can ask questions that are related to these problems. I want us to look at a few examples, maybe just one. One example where we can apply number patterns in real life. Let's look at this example that I took from your book. These are designs that are made out of matchsticks. And we are asked in question number 1 to determine the number of matches in designs 4, 5, and 6. So you need to study the pattern that is given, and then you can be able to answer the questions. Like in the first design, you will notice there are altogether 6 matchsticks that are used. In the second design, in addition to the 6, it's just a matter of counting. In addition to the 6 sticks that were there, you will notice 1, 2, 3, 4, 5 more were added. So 5 more were added. This one there, and that one, and that one, and that one, and that one. These are the additions to the initial 5. So we started off with, in design 1, 6 of these. But in design 2, 5 more are added. So if you count the sticks there, you should get 11. If you check again in design 3, it is just another 5 that is added to whatever was there in 2. So this is 1, 2, 3, 4, and 5. So we just added 5 more. And so the 5 is added to 11, which is why this one will be 16. Now, in question 1, we want to determine the number of sticks or the number of matches in designs 4, 5, and 6. And if you study this diagram, you will notice that there is a constant difference of 5, which means we have to just keep on adding a 5. And therefore, in design 4, we should get 16 plus 5, which is 21. In design 5, we should have 21 plus 5, which is 26. In design 6, we should have 26 plus 5, which is equal to 31. Question 2 is asking for the number of matches in design n. That is the same thing as finding Tn. So we need to know Tn. The design numbers can actually be used as the positions. So this is position 1, and this is position 2, that is position 3, that's position 4, and so on, and that is position n. We know that in position 1, we have a total of 6 matches. In number 2, we have a total of 11. In number 3, we said we have a total of 16. Those 3 will be enough to give us the answer. To get Tn, we want to use the connection that is there between the position and the constant difference. Our constant difference in this case is equal to 5. Now, if you take, for instance, the position, let's work with 6 first. If you take 1, which is the position of 6, and you multiply that by the constant difference, which is 5, your answer will be equal to 5 and not equal to 6. But for you to get a 6, you will notice that you need to add a 1. Now let's check whether we do the same thing for the second term, which is 11. If we take the position, which is 2, and multiply it by 5, we do not get 11. But if we add a 1, we will get 11. You can do the same thing for 16. If you take 3 and multiply by 5, you don't get 16, you get 15. Then 15 plus 1 will give you 16. So what this means then is the general term, which is Tn, should be given by the position multiplied by the constant difference plus 1, because that is what we are doing for the others. And so the answer should be 5n plus 1. All right. Let us look at number 3. We want to determine the number of matches in design 200. That means we are looking for T200. That is what we need. But we need to know Tn in order for us to determine T200. We said earlier on, Tn is equal to 5n plus 1. Therefore, to get T200, we do the same thing. 5 should be multiplied by 200. And then we add a 1. And that should give us 1001. All right. Question 4 is asking which design will contain 601 matches. Once again, we use the same formula. Tn is equal to 5n plus 1. But in this case, we are given Tn. Tn is 601, so we put 201 here, which is equal to 5n plus 1. So when they ask which design will contain 601 matches, they are asking for the position of 601. So we are looking for n. We will then collect our like terms like normal, and that will give you 600 is equal to 5n. Then if you divide by 5, you should get 120. Therefore, that means T120 is equal to 601.